Volcanoes are among the most dramatic and awe-inspiring natural phenomena on Earth. They hold the power to create and destroy, shape landscapes, and even influence the course of human history. But what exactly are volcanoes, and why do they erupt? How have they shaped our planet over billions of years? Today, we'll dive deep into the fascinating world of volcanoes, exploring their formation, types, impacts, and the intricate ways they interact with the Earth's systems. Let's start at the very beginning, beneath our feet. The Earth's structure plays a critical role in volcanic activity. The planet is made up of several layers: the solid crust on which we live, the mantle beneath it, and the outer and inner cores at its center. The mantle, though solid, behaves like a slow-moving fluid over long periods due to the immense heat and pressure it experiences. This is where magma, the molten rock that fuels volcanic eruptions, originates. Magma forms when parts of the mantle or crust melt, usually due to tectonic activity. At tectonic plate boundaries, plates either collide, pull apart, or slide past each other. These interactions create the conditions necessary for magma to rise to the surface. When magma escapes through cracks in the Earth's crust, it erupts as lava, along with gases and ash, giving birth to a volcano. Volcanoes are not distributed randomly across the globe. They are concentrated along tectonic plate boundaries. The Pacific Ring of Fire, a horseshoe-shaped zone around the Pacific Ocean, is home to about 75% of the world's active volcanoes. This area is a hotbed of tectonic activity, where the Pacific Plate collides with, slides beneath, or moves alongside other plates. Now, let's look at the different types of volcanoes. There are three main categories based on their shape and eruption style: shield volcanoes, composite volcanoes, and cinder cone volcanoes. Shield volcanoes, such as Mauna Loa in Hawaii, are massive but have gentle slopes due to their fluid lava flows. These volcanoes produce less explosive eruptions and can create vast landscapes over time. Composite volcanoes, also called stratovolcanoes, are tall and steep. They are built by alternating layers of lava and ash from both explosive and quieter eruptions. Mount Fuji in Japan and Mount St. Helens in the US are iconic examples of this type. Finally, cinder cone volcanoes are the simplest and smallest, forming when lava erupts explosively, breaking into fragments that fall around the vent and accumulate into a cone shape. Volcanoes can also be classified by their activity level. Active volcanoes are those currently erupting or showing signs of activity, like Mount Etna in Italy. Dormant volcanoes, such as Mount Kilimanjaro in Tanzania, are not currently erupting but could become active in the future. Extinct volcanoes, like Shiprock in New Mexico, are no longer expected to erupt. Eruptions themselves can vary dramatically. Some, like those of Kilauea in Hawaii, are relatively gentle, with lava oozing slowly and predictably. Others, like the eruption of Mount Vesuvius in AD 79, are catastrophic. This infamous eruption buried the Roman cities of Pompeii and Herculaneum under meters of ash, preserving them for centuries as a snapshot of ancient life. Even more powerful was the 1815 eruption of Mount Tambora in Indonesia. The explosion was so massive that it ejected an enormous volume of ash and gas into the atmosphere, reducing global temperatures and causing what became known as the year without a summer. Crops failed, livestock perished, and millions faced starvation in the aftermath. But volcanoes are not just agents of destruction. They are also creators. Volcanic eruptions build new landforms, such as the Hawaiian Islands, which were entirely formed by volcanic activity over millions of years. The minerals in volcanic ash enrich soils, making regions around volcanoes some of the most fertile on Earth. The volcanic soils of Italy, for example, have supported agriculture for centuries, giving rise to thriving vineyards and olive groves. Volcanoes have also profoundly influenced human culture and mythology. Ancient civilizations often viewed them as sacred or as the domains of gods. In Hawaiian culture, Pele is the goddess of volcanoes, embodying both their destructive and life-giving powers. Meanwhile, Mount Olympus in Greece, home to the gods of Greek mythology, is itself a volcanic mountain. From a scientific perspective, volcanoes are windows into the Earth's interior. The gases released during eruptions provide clues about the composition of the mantle and the atmosphere's evolution. Volcanic rocks and minerals help geologists understand the Earth's geological history and the processes that shape its surface. Modern technology has vastly improved our ability to monitor and predict volcanic activity. Instruments like seismographs detect earthquakes caused by rising magma, while gas sensors measure changes in volcanic emissions. Satellites track ground deformation, providing early warning signs of potential eruptions. While predicting the exact timing and magnitude of eruptions remains challenging, these advancements have saved countless lives by enabling timely evacuations. Volcanoes also play a role in the broader Earth system. Volcanic eruptions release greenhouse gases like carbon dioxide, but they also emit sulfur dioxide, which can form particles that reflect sunlight and temporarily cool the planet. This dual role highlights the complex ways volcanoes interact with climate systems. Looking to the future, scientists are exploring ways to harness volcanic energy for sustainable purposes. Geothermal energy, generated from the heat of underground magma, is a clean and renewable resource already used in countries like Iceland and New Zealand. By tapping into this energy, we could reduce reliance on fossil fuels and move closer to a sustainable energy future. Volcanoes are more than just geological phenomena. They are powerful, multifaceted forces that shape the Earth and its ecosystems, influence the climate, and even impact human societies. They remind us of the dynamic nature of our planet, capable of both destruction and creation on unimaginable scales. The next time you see a volcano, whether it's a distant peak on the horizon or footage of an active eruption, take a moment to appreciate the incredible forces at work. These fiery giants are not just natural wonders, they are vital pieces of the puzzle that makes Earth the extraordinary planet it is.